Hi everyone. We're going to start a new unit today on rational expressions, equations, and reciprocal functions. And today what I really just want to focus on are rational expressions because each of those three things is a big topic. And while they're related to one another, there are some big distinctions between the three. So I just want to talk about rational expressions today, and we're going to spend quite a bit of time just on rational expressions. So let's get started. Okay, so the first thing I want to do is talk about what a rational expression is. And to do that, I want to remind you of the fact that you have actually, seen the words rational. Oh, what's going on here? That's what I want to do. You've seen the words rational and you've seen the words expression before. Okay, so you've seen the word rational in rational number. And a rational number is a number that can be written as an integer over an integer as long as the second integer isn't 0. Okay, so that's the mathematical definition, but usually we refer to these numbers as things that can be written as fractions. Okay, so anything that can be written as a fraction is rational. Okay, provided that the numbers in the numerator and denominator are not irrational numbers like pi or the square root of 2 or something like that. Okay, so that's what a rational number is, a number that can be written as a fraction. Okay, an expression, a mathematical expression, is something that has a variable in it. Okay, mathematical expression, something that has a variable but doesn't have an equal sign. That's where the equation is actually going to come in a couple days from now. So if we put these together, rational expression, what we're going to be looking at are algebraic fractions. That's what these things look like. Now, to get even more specific, a rational expression is a sort of algebraic expression where specifically the numerator and the denominator are both polynomials. Okay, so it's going to look like this: a of x over b of x, where both a of x and b of x are polynomial expressions. Okay, so there are 3 examples down here of rational expressions. 4a over 3bc. Okay, this is an example where you have a monomial over a monomial. X minus 1 over x squared minus x minus 6. This is an example of a binomial over a trinomial. And 2y squared over y squared minus 4, that's an example of a monomial over a binomial. Okay, these are all examples of rational expressions. Okay, some non-examples. I think showing some non-examples can also really help. Okay, some non-examples would be something like the square root of x over the cube root of x. Okay, because the square root of x is not a polynomial expression. Okay, it's a radical expression. Same with the cube root of x. So that would be a non-example. Okay, these 3 are all rational expressions though. Okay, and what we're basically going to learn to do when we look at rational expressions is the exact same thing that we do with fractions. We're going to learn to simplify them or reduce them. We're going to learn, well, with fractions we call it reducing or simplifying. With rational expressions we call it simplifying. Okay, we're going to learn to add, subtract, multiply, and divide these things. Okay, once we have a rational equation, hint, hint, that's when we have a rational expression within an equation, we're going to look at, well, how do we solve an equation that includes a rational expression? Okay, so that's what we're going to be looking at in this unit. Okay, now there is one thing that rational expressions have that regular rational numbers do not have, that we have to think about. And that is something called a non-permissible value. And sometimes these rational expressions have more than one non-permissible value. Okay, and a non-permissible value is any value of in the variable that would make the denominator equal to 0. Okay, because when we divide by 0, we get an undefined value, and we don't want our expression to be undefined. So any value of the variable that makes the denominator 0 is called a non-permissible value. Okay, so for example, if you look at this first one, 4a over 3bc, and we want to know what are the non-permissible values, or we call them NPVs for short. Well, we have to look at first, what are the variables in the denominator? Okay, a is not in the denominator. A 0 in the numerator in a fraction is totally okay. It is defined. 0 over 4 is equal to 0. So that's totally fine. But you cannot have a 0 in the denominator. Okay, 1 divided by 0 is an undefined value. So we have to think, okay, we're multiplying 3 times b times c in the denominator. What values of b and c would make the denominator equal to 0? And in this case, b equaling 0 would make the denominator 0, because 3 times 0 times c is 0. And also c equaling 0 would make the denominator 0. So the non-permissible values are b cannot equal 0 and c cannot equal 0. Okay, that is how we would state the non-permissible values. Okay, now in this case, this was a monomial. So in one sense, this was sort of factored, because we can see what are the things that we're multiplying together in the denominator. We're multiplying a 3 times a b times a c. In this second example, x minus 1 over x squared minus x minus 6, to figure out what values of x would make the denominator equal to 0, we need to have the denominator factored. And in fact, just to figure out non-permissibles, all you have to do is factor the denominator. But my sort of mantra in this unit is, when in doubt, factor. So you will want to factor everything, because you'll see when we the more we do with these things, you're going to want numerators factored as well. Okay, so try and factor everything. Now, in this case, the numerator is already factored, so let's not worry about that. But we need to factor the denominator, because if we can see what are the two things that are multiplied together to get the denominator, we can figure out what value of x would make that denominator 0, and that would be the non-permissible value, or the non-permissible values. Okay, so let's factor this denominator. The numerator is already factored, it's just x minus 1. And here we have to think, okay, this is a trinomial of the form ax squared plus bx plus c. The a value is 1, so this one's relatively easy to factor directly. We're looking for two things that multiply to -6 and add to -1. Okay, so that would be -3 and 2. This is going to factor into x plus 2 times x minus 3. Okay, and we can see here, okay, we're multiplying two things together, x plus 2 and x minus 3. What values of x would make either one of those equal to 0? Well, if x was -2, then -2 plus 2 would be 0, and then the entire denominator would be 0. So from this factor, x cannot equal -2. And from this factor, x minus 3 can't equal 0, because if this factor equaled 0, again, the whole denominator would be 0. So what value of x would make x minus 3 0? That would be 3. 3 minus 3 is 0. So x cannot equal 3. And those are the non-permissible values. Okay, so you could write non-permissible values, -2 and 3. And because there's only one variable here, you can kind of write it out like a list, like I did at the top here. In the first example, there were two variables. So we had to specifically say b can't equal 0 and c can't equal 0. When we only have one variable, you can list it this way. You can say x cannot equal -2 or 3. Okay, you can state that either way. Or you can do it the way that we did it here at the bottom. That's fine too. Okay. All right, let's try another one. So here we have 2y squared over y squared minus 4. So here the denominator is a binomial, and it looks like it's a difference of squares. So Numerator is already sort of factored. It's just a monomial. So I'm going to factor this, y plus 2 times y minus 2. Okay, so the values of y that would make the denominator 0 are 2 and negative 2. And when it's the same number but both signs, as in negative 2 and positive 2, you can write that as plus or minus 2 if you want. Okay, or you could write it as y cannot equal negative 2 or 2. Okay, same thing. Okay, so now typically what we like to do with these things is simplify them, just like we simplify fractions. Okay, now I want to remind you, when you have fractions, so I'm going to go a little bit off topic here just for a second and remind you of what happens when you simplify fractions. Okay, so when you simplify fractions, I'll just maybe do this off to the side. If you have something like 4 over 6, you guys don't even think about that anymore. You just say, okay, that's 2/3. Okay, so most of you, I'm thinking probably 100% of you can just do that in your head. But what's actually going on when you do that is you're looking at what is the prime factorization of 4 and what's the prime factorization of 6, and then what are the common factors in the numerator and the denominator. Okay, and that all happens in your head because you've done this for so long. So let's break that down. And the reason why I want to break it down is because that's what we have to do when we simplify rational expressions. So 4 over 6 is actually 2 times 2. Over 6 is 2 times 3. Okay, that's kind of the intermediate step. And then we have this 2 over 2 here. And 2 over 2, 2 divided by 2 is equal to 1. So we can cancel those out. And that's why 4 over 6 is equal to 2/3. Okay, now you can do this with bigger fractions as well, right? You could do it with, I don't know, let's see, 36 over 84. Let's try that one. Okay, so if I maybe prime factorize 36, I'm going to get 2 times 18, 2 times 9, 3 times 3. Okay, and if I do the same thing for 84, I have 2 times 42, 2 times 21, and 3 times 7. Okay, so I can also reduce fractions this way if I want. I can sort of prime factorize these things, right? Break them down into the smallest possible pieces. So that would be 2 times 2 times 3 times 3 for 36 over 2 times 2 times 3 times 7, 2 times 2, oh, whoops, 2, there we go, that's better, times 2 times 3 times 7. And then I can cancel all the common factors, right? So I've got common factor of 2. 2 over 2 is 1. Another 2 over 2 is 1. And 3 over 3 is 1. So this all reduces to 3 over 7. Okay, so you can do this with numbers as well. We just don't usually do that because we've been doing this with numbers for so long that we don't have to think about it so much anymore. Okay, now this process of factoring things down to their smallest of parts that we just did with numbers is exactly what we're going to do with rational expressions. There's just one caveat, and that caveat is that we have to think about non-permissible values as well, which we don't have to do with numbers. Okay, so that's what we're going to do over here. All right, now we have to factor first. That's the first step. Factor everything. And in fact, that's over here. Factor everything. State your non-permissibles. The reason you have to state your non-permissibles before you reduce is that the non-permissibles apply to the original expression, not the reduced expression. Okay, so that's what we're going to do. Now this first guy, 2y squared plus y minus 10, you may have to do a decomposition there, or you may want to try starting to do some guess and test. Okay, so if I just factor that separately, right? We can do decomposition first. If you're factoring 2y squared plus y minus 10, you're looking for two numbers that multiply to 2 times negative 10, negative 20, and add to the coefficient of b, which is 1. Okay, so those two numbers would be negative 4 and 5. So when you're factoring this, we're going to break the middle term down using these two numbers. So we're going to get 2y squared minus 4y plus 5y plus 10. And then we can factor the GCF out of the first two terms and the last two terms. So 2y would be the GCF there, and we're left with y minus 2. Oh, I'm sorry. This is a minus 10. That's better. And then in the last two terms, the GCF is 5. So plus 5 times y minus 10. Nah, minus 2. Hold on. I have to fix this. This is too many mistakes. That's better. Okay. All right. Let's fix that. I could live with one mistake, but not that many. Okay, so this was y minus 10, and this is y minus 2. That's better. Okay, now I have a GCF binomial of y minus 2. So I can bring that out in front, and I've got y minus 2 times 2y plus 5. Okay, so you can do that. That's the first trinomial that we have to factor, and then we got to do the second one as well, which is y squared plus 3y minus 10. Okay, and here this one's a little easier because the coefficient of a is 1. So we're just here looking for two numbers that multiply to negative 10 and add to 3. And those two numbers are 5 and negative 2. So y plus 5 and y minus 2. Okay, now one thing that I do want to mention though is with this guy over here, okay, if you can start to try to factor that using guess and test, you may find that after a little bit of practice, it gets faster. So I'm just going to demonstrate for you how I would do this. And I've done this before in class, but because this unit involves so much factoring, this is really where you might want to start working on those skills. Okay, so I know if this is going to factor, that it's going to factor into the product of two binomials. Okay, and because I need the first term in each binomial to multiply out to 2y squared, I know that my only options for the first two terms are 2y and y. Okay, because that's how I know that I'm going to get 2y squared. Okay, now I've got a few options for the negative 10. For my negative 10, I could have negative 2 and 5. I could have 2 and negative 5. I could have 1 and negative 10, or I could have negative 1 and 10. Okay, and you could start with any one of these when you're guessing and testing, but when the middle number, when the middle coefficient, I should say, is not really large relative to the other two values, relative to the A and C value, it's usually an indication that you should start in the middle rather than at the extremes. Not always, but usually. Okay, so that's where I'm going to start. Now, when I start plunking these things in, another indication of where does each one go. Now, I know, just because I've done this a lot, the negative 2 can't go here. Or the 2 can't go here. Because if the 2 went here, or the negative 2, I'd have a GCF of 2 here, which means the entire polynomial would have a GCF of 2, and it doesn't. So this has to be the 5. If the two numbers are 5 and 2, right? And again, if you didn't get this the first time, you'd just guess and test and you'd be done with it, right? If it doesn't work out, you throw it away, you try something else. So I'm going to try out 5 and 2. And let's say I think that this is negative and positive first. Let's say I try those ones, okay? Now, by choosing one of these four options, I've ensured that my last term is going to be negative 10. So I don't need to worry about my first term, the 2y squared, don't need to worry about the negative 10. Okay, what I need to think about is what is this middle term going to be? And to do that, I need to go, okay, 2y times 2 is 4y, and then negative 5 times y is minus 5y. 4y minus 5y is negative y. That's not what I want. So I'm going to switch it around, and I'm going to get the eraser out again, and I'm just going to switch the signs. Okay, so I'm going to try making this instead a plus and a minus, and then I'll test again. So I have to test 2y times negative 2y is negative 4y plus 5y is 1y, and that's exactly what I want. Okay, and I know it might seem like it's slower initially, but once you start to do this a lot, and you will do it a lot in this unit, you may find that guess and test becomes really fast. Okay, so once you have them factored, I know I went on a bit of a tangent there, that's just step 1. Okay, this was all step 1. Factor. So now we have it factored, and what we have is numerator over denominator, 2y plus 5 over y minus 2 over y plus 5 times y minus 2. Okay, so that was all the first step. Second step, non-permissible values. Okay, and for the non-permissible values, you only look to the denominator because, again, it doesn't matter if the numerator is 0. The numerator is allowed to be 0. Okay, so in the denominator, what value of y would make the denominator of 0? From the first factor, it would be negative 5, and from the second factor, it would be 2. So y cannot equal negative 5 and 2. That's the third step, or second step rather. Third step, cancel common factors. To be a common factor, the factors must be identical. So these are identical. These two are not, because one is 2y plus 5, the other one is y plus 5. So the final answer is 2y plus 5 over y plus 5 with these two non-permissible values. Okay, this is the third step. All right, let's try a couple more. Okay, so step 1, factor everything. Okay, so that's what I'm going to do. I'm going to factor the numerator. In the numerator, okay, I've got a GCF of 2. So I'll factor that out, and I'm left with 3 minus m. And in the denominator, I've got, this is a difference of squares. So I can factor this as m plus 3 times m minus 3. Okay, now it might look like, and actually I'm getting a little ahead of myself. I should at this point state non-permissible values. Okay, so looking at the denominator, the two non-permissible values from the first factor are negative 3, from the second factor are 3. So m cannot equal negative 3 or 3, or you could write it as plus or minus 3 if you want. All right, now let's talk about what can we cancel. This is step 2. And it looks like we can't really cancel anything because it looks like none of the factors are identical. Okay, here's the thing though. The first factor in the numerator, 3 minus 5, and the second factor, m minus 3, differ by a negative sign. So if you think, for example, I'm just going to do this with numbers, 10 minus 5 over 5 minus 10, or 7 minus 3 over 3 minus 7. Okay, so basically we're looking at subtraction, but the order of the terms is reversed. What you get is 5 over negative 5, or 4 over negative 4. Okay, so these two binomials will have the same value but opposite signs. This is equal to negative 1. This is equal to negative 1. Now, why does that happen? Well, instead of factoring out a 2, we could factor out a negative 2. So if I factor out a -2 instead, then this 3 will have to be a -3 because -2 times -3 is +6. And this -m will have to be a +m because -2 times m is -2m. So if you take a negative sign out as well, the signs on the inside will switch. If they were negative, they will become positive. If they were positive, they will become negative. And now, I have a binomial that's common to the numerator and denominator. -3 plus m is the same as m minus 3 because the terms inside the polynomial are the same. Although they're in the opposite order, the signs in front of each term is consistent, right? The m is positive, the 3 is negative. So these can now be canceled. Okay, and so this simplified is -2 over m plus 3. Okay, so this over here would be step 3. So you would be expected to know that you need to factor out a negative sign if the order of the terms is reversed with subtraction. Okay, with addition, it doesn't matter, right? M plus 3 is the same as 3 plus m, but with subtraction, it does. 3 minus m is not the same as m minus 3, but we can make that factor the same if we factor out a -1. All right, let's look at one more. Simplify and state the non-permissibles for 16x squared minus 9y squared over 8x minus 6y. Okay, so this is a rational expression that is in two variables. So let's start out by factoring, and then once we factor, we'll figure out the non-permissibles. Okay? All right, so difference of squares, numerator's difference of squares. So we'll factor that. And the first perfect square is 16x squared, so the square root of that is 4x. So that's the first term. Square root of the second term, 9y squared is 3y. One of them's plus, one of them's minus. Okay, so that's the numerator factored. The denominator factored, there's a GCF of 2. So I can take a 2 out, and I'm left with 4x minus 3y. Okay, well that's kind of nice because we can see that there's a common factor that's going to cancel. But we've got to state non-permissibles. Okay, now for non-permissibles, really, when you're finding a non-permissible, 4x minus 3y cannot equal 0. Okay, now if you want the non-permissible in terms of x, you have to isolate x. If you want the non-permissible in terms of y, you have to isolate y. Now we want the non-permissibles in terms of both because we need to state them. There's an x and a y in the denominator, so we've got to state both. Okay, so we have to take this single equation and isolate x and isolate y. Okay, so let's do that. First thing that we're going to do is, put the x's on one side, the y's on the other. And essentially, we're treating this exactly as we would an equation, except instead of an equal sign, we have a do not equal sign. Okay, so we're going to have 4x does not equal 3y. Okay, so x does not equal 3 over 4y. That's one of them if we isolate for x. If I take the same thing and isolate for y, then I'd have to divide both sides by 3. So I'd have 4 over 3x does not equal y. That's my other one. Okay, so those are my two non-permissibles. So I'm just going to stick those both there. Okay, so y does not equal 4 over 3x. X does not equal 3 over 4y. Okay, so I've stated one in terms of the other for both variables. Or in other words, I've isolated each variable. Okay, so that's step 1. This is step 2. Step 3, I can cancel common factors. So I can cancel these. And I got 4x plus 3 over, or 3y rather, over 2. There we go. Okay, now, what is the MPV for x when y equals 3? Well, this is why it's important to state one in terms of the other. If y equals 3, x cannot equal 3 over 4y. So x cannot equal 3 over 4 times 3. And this is 3 over 1, right? So that would be x cannot equal 9 over 4. Okay, and then finally evaluate the expression for x equals 1.5 and y equals 2.8. Well, this is the nice thing about simplification. Once we've simplified, okay, as long as x doesn't equal 3/4 y, which it doesn't, 1.5 is not 3/4 of 2.8, or y does not equal 4/3 x, which it doesn't, then we can go ahead and plug these in to the simplified expression, which is much nicer to plug in than the original. So that simplified expression, right, is 4x plus 3y over 2. So 4 times 1.5, is it plus or minus? Hold on, plus 3 times 2.8 over 2. And that is 6 plus 3 times 2.8 is 8.4 over 2, which is, I'm running out of space, 6 plus 8 is 14. So 14.4 over 2, which is 7.2. Okay, so that's all I have for today. That's just what we're going to look at in terms of defining these things, defining non-permissible values, and talking about simplification. And simplification of these is the equivalent of reducing fractions. Tomorrow, we're going to start talking about how do we multiply and divide these rational expressions. And I'll see you guys all later.